Okay, we start lecture. Today topic is rotational dynamics. This is your first chapter, class 12 science, subject physics, and their marks is probably 5 to 6 mark chapter. And I'm your teacher. I teach you physics first, fourth chapter. Okay. So first we will understand what do you mean by rotational dynamics. So dynamic is derived from the word. There is a branch of physics in which there are three types of branches there. One is thermal, one is mechanical, and third is dynamic. So dynamic is mean motion. Okay. In rotation dynamics, we will study two chapters or two topics. One is circular motion, and second we will study the rotational motion. Now first we start circular motion. What do you mean by circular motion? So see the example here. The moon is revolving around the earth, right? The motion of, suppose moon is an object, so motion of an object along the circumference of the circle is called circular motion. I hope you understand. Now this moon is revolving around the sun in circular orbit, right? This is called circular motion. Next, in circular motion we have two types of circular motion. One is called uniform circular motion and second is called non-uniform motion. Non-uniform circular motion. Uniform circular motion is also called UCM and non-uniform circular motion is also called non-UCM. I hope this part is clear, everyone. Okay, we will go further. Now, one by one we study each type. One is uniform circular motion. What is uniform circular motion? See the example. The car moving in a circular path or circular road at constant speed. So the speed is constant. So this type of circular motion is called UCM. See the definition. Suppose an object or particle is said to perform uniform circular motion if it moves in a circle or a circular arc, right, at constant linear speed. Here scientist says the motion is constant. Their speed is in each place. Their speed is same, constant. There is no change in speed. That is why we are called uniform. The word uniform itself represents the constant. Okay. Now second we see the example of non-uniform. See the car. The car is moving on the some circular part. So their speed is changing. See, from starting we have to increase their speed so that they are complete their circular motion. So in each place from down to up their speed is changed. At starting position, at down position their speed is high, large, and at top position their speed is changed, right? Their speed is not same. So the speed is variable, right? Then in this case we are saying this type of motion is non-uniform circular motion. Clear? The motion of a particle along the circumference of the circle with variable speed is called non-uniform circular motion. Clear? This part is clear? वॉइस आ रही है तो उसके लिए म्यूट कर दो, म्यूट योर ऑडियो. This part is clear. Non-uniform circular motion. Yes. Next is the radius vector. What is the radius vector? Now from center, suppose we have one point or object. They start their position from point P1. Okay. So from center to that point distance is represented by the direction. We are using the geometry property. So this arrow represents the position of the object and this arrow position is represented by radius symbol, radius vector symbol R1. That is why we are calling this radius vector. So what is the definition of radius vector? In circular motion, see the circular motion. The vector drawn. Here we are represent the vector drawn from the center of the circle to instantaneous position. Instantaneous position we are represent the small change in position of a particle on the circumference of the circle is called radius vector. I hope this is clear. Now radius vector is also called position vector. Why we are calling position vector? Because this radius vector represents the position of the object. Clear this part? Okay. Here R1 is represent the radius vector or position vector. So it is necessary. See, first case our object is position 1, right? P1. Now second case my object is second position. In each place their direction their magnitude of direction is same. Magnitude, what do you mean by magnitude? I already told you about magnitude. Magnitude represent the quantity. Now in each case the direction or quantity of direction is same. From center to circumference distance is same. Radius is always same. तभी तो circle बनेगा. That means each place their radius is same. Correct? If the radius is same, that means that their magnitude is same. So we can represent R1 is equal to R2, right? But their direction is same? No. From this place they are somewhere else. P1 position is different and P2 position is also different, right? So each place their position is not same. So this means that direction is changed, right? That is why based on vector symbol R1 is not equal to R2. So there are SI unit. Here we are understanding the distance. That is why the unit is represented by meter and the dimension is M0, L1, T0. This part is clear. Radius vector. What do you mean by radius vector? Okay, we go further. Angular displacement. Angular displacement. The displacement is nothing but distance. Angle, based on angle we are studying the distance. Let's see the example. Suppose our object is from the position A and they perform the circular motion and they reach the destination from the position B. So they start from where they start from point A. Once they start here, then they are going to the point B, right? So their covered distance is just like a arc, is represented by S. From center point O, suppose here one person is standing and they are watching the object. Suppose this is a car. So the car starts from point O and they are going from the point B. From center we see the one angle is and an angle is there, right? This angle represents their distance, right? So anything which performs circular motion in that distance is represented by their angle, right? From A to B there are some angles. From A to some other distance the angle is changed. So these angles represent the object distance. That is why we are calling angular distance or angular displacement. Understood? Let's see the definition. In circular motion, the angle traced by vector. See, from center O, the position is represented by R. In each place we are represent the position by R. This is position vector A. Here position vector B. Correct? In each place, see the angle. This angle, what this angle represents? The position from A to B. Correct, na? Normally we are using the method length or scale for measuring any distance, right? For example, if I want to measure the distance of table, what we are using? Scale, right? But if anything performing circular motion और कोई भी चीज कर्व पाथ पे परफॉर्म कर रहा है, so how to find their distance? At that time scientists said don't use scale, we are using the another method that is called angle. With the help of angle we can easily measure the distance of any object which performs circular motion. Understood? So these are the methods. Okay, let's understand this formula. Now angle represents the distance of object. So how to calculate distance? We are calculating their A to B ka distance is S and we see the position from position A to from position B. So see that definition. Angular distance is nothing but the ratio of their object distance and their position. Understood? So I hope formula is clear. कैसे formula clear किया? This formula is their definition. ये बोलो, either you write this, understand this part. Can you write this formula? Take this R from left side. What we are getting? S is equal to R theta. Right? Remember this formula. Now, from position B to C, the object performs a small distance. From B to C is very small distance. So small distance, how to represent small distance? We are representing by delta symbol. Delta S. Obviously, if distance is small, their angle is also small. So theta is represented by delta theta. And what we call small distance in physics, we are represented by instantaneous work, right? Instantaneous angular displacement or instantaneous angular distance. Both are vector quantity. Why we are representing vector quantity? Because it represents the position. See, the how they are traveling, the object, clockwise direction or anti-clockwise direction. Common sense, we will see they are performing clockwise direction, right now. So that is why we are calling this is vector quantity. Okay. Next, again take r from left side. What we are getting, delta s is equal to r delta theta. This equation based on magnitude vector form equation. How to make vector form equation? It's simple. We are representing the arrow. Okay. We are representing by the arrow. Okay. This arrow represents the direction. Okay. SI unit is, now theta SI unit is radian and the dimension is m0 L0. There is no dimension for radian. Now second, how to find the direction? So for finding the direction, we are using the right hand rule. Okay. What is the right hand rule? We already know about the right hand rule. In finger, stretch a rod in your finger, then your finger represents the direction of motion and your thumb represents the actual direction where this motion occurs. In finger, in right hand rule, the finger represents the circular motion direction and the thumb represents the displacement direction. इसका example we will see the fan example. How fan is moving or where they give their air, right? It all represented by right hand thumb rule. Now definition of radian. What is radian? Yes. Okay. So थोड़ा और simple करते हैं. We will see. Now in right hand thumb rule, the curved finger represents the circular motion and the thumb represents the direction of motion. Clear? If the motion is clockwise direction, so the direction of motion is downward. If the motion is anti-clockwise direction, see here, the finger is half this. We are first understanding the basic part. This is the first page, introductory part is there. Okay. Now see the finger here. This finger represents the anti-clockwise direction, right? Circular motion, anti-clockwise direction. So the direction of motion is always upward. Okay. We will see the example. Direction of motion is upward. Okay. Definition of radian. So we already know about the radian. What is radian? One revolution. If particle perform one revolution, in one revolution they cover how much angle? In one revolution, in one complete circle, what is the degree of one complete circle? Is 360 degree. In radian, how we represent this degree? By 2 pi radian. Clear? So pi is represent 180. So 2 multiplied by pi is 360 degree. Clear? Next is angular velocity. What is angular velocity? Now same definition. Linear velocity ka definition we already know. With the help of this, we will understand this. Okay. So linear velocity definition is distance upon time. Correct. Similarly, in angular velocity, here angular velocity distance is represented by angular distance, and time is represented by as it is time. Clear? Now we will understand with the help of example. Suppose object is at initial position A, then they perform a motion and they reach the position B. They cover a distance. That distance is represented by angle theta 1. Now they cover the distance from position B to C. Clear? So they cover one more angle. That angle is represented by from initial to final theta 2. Now here first they start from position A, then they reach from position B, then they reach from position C. So we have to find their average angular velocity. So how to find average angular velocity? Very simple. Write change in velocity, the difference between two distance and the difference between two time intervals. So change in angular displacement upon change in angular time. Now change is represented by negative sign. So that is why we are using here negative substitution. Yes. Okay. What we are not understanding, tell me. You know about the basic definition of velocity? Okay. Average velocity represents the total velocity from position A to B to C. From position B, they are covered some distance. So their velocity, how to find the velocity? We are using the basic formula, na? Distance upon time. Correct, na? So we can use that formula here, distance upon time. Here distance. Now we are finding the angular velocity, na? The angular velocity का symbol is different, omega. Understood? And angular displacement symbol हम लोग को लेफ्ट साइड से मिला. क्या सिंबल था? एंगुलर डिस्प्लेसमेंट. नाउ हियर वी आर नॉट यूजिंग द प्रीवियस फॉर्मूला सिंबल. हियर थीटा वी आर रिप्रेजेंट. थीटा, व्हाट थीटा इज रिप्रेजेंट? थीटा हियर रिप्रेजेंट द एंगुलर डिस्प्लेसमेंट. ओके, 1 मिनट. मुझे थोड़ा सा